Hello, I'm Brian Young. Today we're doing Module 26106, Outlet, Device, Pull, and Junction Boxes. Let's get started. Outlet, Device, Pull, and Junction Boxes. Successful completion of this module prepares you to explain how to size and install outlet boxes. Explain how to size and install pull and junction boxes. Under supervision, you'll be able to do the following. Select the appropriate box type and size for a given application. Select the minimum size pull or junction box for the following applications. Conduit entering and exiting for a straight pull. Conduit entering and exiting for an angle pull. In the overview, it says electricians work with electrical boxes almost every day on every project. Electrical boxes are enclosures that hold and protect the wiring for the electrical devices such as switches, outlets, lighting fixtures. To safely and properly install a complete electrical system, you must know how to select, size, and install all types of electrical boxes. In this module, you'll explore the application of different electrical boxes. You'll also learn how to calculate the National Electrical Code fill requirements for outlet and junction boxes under 100 cubic inches. Sometimes these different boxes, a pull box, a junction box, an outlet box, they're not different things. It's a box, and you use it for what you need it for. If you're putting a device in it, like a receptacle and a switch, then it's a device box. If you're using it for a lighting fixture, it's an outlet box. If you're just using it to tee off, it's a junction box. But there aren't specific boxes that are named these things. It's the boxes that we use to enclose our wiring. So don't get confused on the job. Using smaller electrical boxes. We'll learn how to identify outlet boxes and their applications, summarize the NEC requirements for sizing outlet boxes, summarize the NEC requirements for installing boxes. It says on every job, electrical boxes are required to enclose the wiring needed for devices. All of them must be sized, installed, and supported to meet the current National Electrical Code requirements. So an electrical box is a metallic or non-metallic box installed in an electrical wiring system to safely house electrical components and or securely mount devices and electrical cables. Specific uses include outlet boxes, junction boxes, devices boxes, splice boxes, and pull boxes. The National Electrical Code tells us that every splice or tap must be contained in a box. You can't just put wires together with a wire nut and tape them up with electrical tape and shove them into a wall. They have to be contained in a box. Same with devices, switches and receptacles, they have to be contained in a box. It says based on the code, you must choose and install boxes that are the correct size to hold all of the conductors that must be spliced in the box or fed through it. The process of selecting and installing electrical boxes are covered in the following sections. 1.1.0, identifying boxes and their applications. Electrical boxes come in many sizes and types. Their size and shape are dependent on a variety of factors, including the application, raceway sizing, number of conductors entering the box, the type of building construction, weather conditions of the area, or other special requirements. So ceiling boxes are sometimes round or octagonal, meaning 8 sides. Conduit bodies have threaded hubs. We can put either a connector and run EMT, or we can put rigid conduit we'll thread into it. Custom assembly. This is a 4 square box, or what some people call a 1900 box, with a mud ring or plaster ring on it. and the drywallers will come and cut that drywall around this mud ring. That's why they call it a mud ring or a plaster ring. And then after they're finished, you get your rough-in inspection. They put the drywall on. We'll come back and terminate these switches in the box. Here's a floor box, handhole enclosure, hazardous location box. A handhole, if you think of it this way, a handhole is big enough to put your hands in. A manhole is big enough for a person to climb into. So handholes are usually 2 feet by 3 feet. They go in the ground. They're flush with the ground and they have a cover on them so that they can support the weight of someone if somebody walks over it. Hazardous location boxes have threaded hubs and gasketed covers to prevent the exchange of atmospheres from a hazardous location to a non-hazardous location. Sometimes they call that intrinsically safe. Here's a junction box. Here's a plastic electrical outlet box. If you're working residential, you'll use a lot of these, either a bracket box or nail-on box. Here's a weatherproof outlet box. Again, some people call it a bell box. It can be made out of PVC, it can be plastic, or it can be metallic, but it has threaded hubs to keep the weather out, the rain and what have you. National Electrical Code Section 314 provides the rules for sizes and shapes of electrical boxes. As an electrician, you need to know how to select the size and type of box you need for each job. You must also know the components needed for terminating the wires in these boxes. So before you can plan and route conductors to their termination points, as well as pick and install the right type of sizes of boxes, you must know the following information. What's the purpose of the box? What's the size of the conductors and the number of conductors? What's the location of the box? The conductor ampacity, the allowances for voltage drop. Electrical boxes usually fall into one of 3 categories. Pressed steel boxes with knockouts of different sizes for surface metal raceways, cast iron or aluminum or brass boxes with threaded hubs for different sizes and locations, or non-metallic boxes. Those are the plastic boxes. Caution says metal boxes are a good conductor, so when you use them, they must be grounded to the circuit grounding system. That's very important to know. Metallic boxes used in concrete parts of a deck are different from boxes used in residential or commercial buildings. There are also different boxes for supporting light fixtures, known as luminaires, securing equipment that is outside. For hazardous locations, you might even need a special box rated as explosion proof. It's designed and built to withstand explosion on the inside without creating an explosion or fire on the outside. When choosing the correct outlet box, it's important to understand the specific use and the environment where the box is being installed. This will help you select the most appropriate box and reduce the chance of wasting time and money. So here's an outlet box with built-in clamps. This is a Romex clamp in the back, wire retainer. So when you put the wire in, there's a screw that you tighten the screw, and this yoke will tighten down onto the 2 Romexes going up into the box, the 2 non-metallic sheath cables. Here's a knockout if you wanted to use conduit of different sizes. This might be a 1/2 inch knockout or a 3/4 inch knockout. Electrical boxes are often ordered with knockouts only. In this case, you'll need to use extra connectors. Regardless of what box is selected, it's important to choose the correct box for the job right from the start. So here's a 4-square box that has knockouts. And this knockout gives you the choice between either a 1/2 inch knockout or a 3/4 inch knockout. They call those concentric. You have 2 knockouts and they share a common focal point, so they're called concentric. If they shared one edge, it would be called eccentric. So you have concentric and eccentric. Let me move ahead here. They're giving a lot of information. Read this on your own. We're going to go on to sizing and figuring out how to count the wires inside the box. A typical box showing a UL stamp. So right here, it's been stamped with Underwriters Laboratory, nationally recognized third-party rating system. So they've tested this box and made sure that it complies to all of their standards and it's safe to use on the job. So they've stamped it with their UL emblem. So NEC section 314.27B states that any box installed on the floor must be listed for the purpose. Listed floor boxes have covers and gaskets to keep out surface water and cleaning products. 314.27C covers the use of boxes to support a ceiling supported paddle fan. When boxes are used as the sole support for a paddle fan, the box should be listed for the application and for the weight that the fan is to be supported. NEC section 314.27C also requires that any box built to support a paddle fan weighing more than 35 pounds shall have a label showing the maximum weight it can support. That's a highlight. So if it's to support a ceiling fan more than 35 pounds, it has to be labeled. It has to have a label on it showing the maximum amount of weight that that box can support. And I believe if the fan is over 70 pounds, it has to be independently supported. You cannot support it from the box. So you'd run some lag screws up into a rafter and support the ceiling fan off of that. Here's a typical way of supporting a ceiling fan outlet box. So you've got a bracket that goes between two of the rafters, and sometimes you can even put additional screws in that go all the way through the rafter, and then the box itself is mounted to this rail, and some of them can hold over 100 pounds. NEC section 314.27D states that boxes used to support equipment other than paddle fans shall meet the requirements of NEC section 314.27A for support of a luminaire of the same size and weight. 1.1.1 Selecting octagon and round boxes. So octagon and round boxes are typically used to mount luminaires on walls. Covers and trim rings that will support receptacles and switches are available for octagon boxes. If the box is used as a junction box, you can get a blank cover for it. These are octagon boxes. If you pay close attention, you're going to see that the octagon box actually only has 4 straight sides where knockouts come out. These other 4 sides have a slight curve to them. That accepts a round fitting or canopy for a fixture or a ceiling fan if you're using a ceiling fan box. So these boxes are not true octagons, and you cannot come into the side that has a curve on it. You're not allowed to come into that side. If you have conduit that must go into the side of the box, do not use a round box. It's hard to make a good connection with a lock nut or bushing on a round surface. Here's some NEC requirements. 314.24A says all boxes must have a minimum internal depth of 1/2 inch. That is the smallest a round or octagonal box can be. For ceiling mounting is 1/2 inch. If a box is to hold a device, it has to have a minimum depth of 7/8 of an inch. Boxes enclosing equipment or devices that project more than an inch and 7/8 into the box shall have a depth that is no less than the depth of the equipment plus 1/4 inch. Boxes that will hold flush devices must not have a depth of less than 15/16. They've increased it by 1/16 of an inch for conductors 14 gauge and smaller per NEC section 314.24B5. So they must not have a depth of less than an inch and 3/16 for conductors of number 12 or 10. So 15/16 for conductors 14 and smaller, and 1 and 3/16 for number 12 or 10. I'll let you look up these sections in your code book, 314.2 and 314.24. We're going to be talking about 314.16a and b, and we're going to be talking about the sections on the number of how many conductors to derate the box. After you install all the boxes in a complicated job, it's a good idea to label each box location. Using a can of spray paint, paint small dots on the floor below each box. Use 1 dot for a plug receptacle, 2 dots for a switch. I'm not going to read that. We've never done that. Different contractors will have you do different things. Do what your contractor wants you to. Here's a non-metallic round box and fixture ring with a bar. This is not rated for a ceiling fan. You cannot use this box to support a ceiling fan. Let's see what it shows here. All right, they're showing a pancake box. It's a 1/2 inch. It's a shallow round box. It's 3.5 inch diameter. Here's your ceiling. That's the drywall. And you're going to use, well, to me, I would have said these would go up into the joist. You'd use lag screws to go up into the joist. They're saying that you can support a lighting fixture from this box using either 832 or 1032 screws to support it. 1.1.2, selecting square boxes. This is a highlight. It says square boxes are typically available in 2 sizes, 4-inch square and 4 and 11/16 square. Both sizes are available in 3 depths, 1.25 inches, 1.5 inches, and 2 1/8 inch deep. If a deeper box is needed, you could use a square extension ring. You can't go crazy on that. You can't put 3 or 4 of them. You can put 1 extension ring. When you start putting a second extension ring, the inspector's going to say you should have used a larger box. So this is an extension ring. It only has the 4 sides, doesn't have a front or a back, so you can use this on an existing box if you need more depth. And they're showing it without these knockouts in. It has knockouts. It has the metal enclosing it, and if you need one, you just knock out the one you need. They just took these away to show you. So square boxes come either with or without mounting brackets. These brackets hold the box to the wall or a stud or other structure. Boxes made for use with cable may have either type AC, MC, or NM clamps for securing the cable where it goes into the box. Let's see what we have here. It says 1.1.3, selecting device boxes. Outlet and device boxes are electrical boxes that house switches and receptacles. They're made for flush mounting, primarily in residential jobs. In some instances, they may also be used on commercial jobs. So here's integral nails for mounting directly to a stud. Here's the depth gauge. You want the box to stick out through the drywall, the depth of the drywall. A lot of them already have a 1/2 inch gauge marked on it. Some of them will have ears or little protrusions that keep the box from going back into the wall any further than it'll leave that 1/2 inch out. If you're using 5/8 drywall on the job, you need to know that. You need to make sure that you hang this box out 1/8 of an inch further than that little 1/2 inch protrusion. This one has a bracket on the side of the box. Again, note that it is a 1/2 an inch setback on the box. That way, when you nail this to the front of the stud, the box will be protruding a 1/2 an inch. So when they put the drywall on, this box will be flush with the face of the drywall. A special single gang box with the devices mounting ears on the inside of the box is called a handy box or utility box. boxes can have a depth of either 1.5 inches, 1 7/8, or 2 1/8 inch. So here's your metal handy box. They're used for surface mounting. You can use them in garages or anything that has a concrete wall. You can mount it right to the wall. They don't have to be set back into the wall. They are not for outdoors though, because of these knockouts. They're not waterproof. Selecting masonry boxes, 1.1.4. Masonry boxes, also known as concrete boxes, come in a variety of heights. This special type of box is typically used in flat slab construction jobs. When using a masonry box on a job site, be certain the box is tall enough to ensure the knockouts are well above the reinforcing rods. Taking this approach can prevent you from having to use offsets in conduit where it enters the box. So this is a floor box and it's flush with the top of the pour. So it's important that you know how much concrete they're going to pour so that you can leave this flush with the top. You tie your conduit down to the rebar. Some of these things you'll learn on the job. They're going to show you. If you are on a slab job, they'll teach you that. 1.1.5, selecting boxes for wet and damp locations. In damp or wet places, it's important to keep water from getting inside the box. You can do this by using the correct box and listed for wet locations. So we have rain-tight or watertight equipment. Rain-tight says something that is built to protect or protected to keep the water during heavy rain under specific conditions out of the box. Watertight, something that is built so that water will not get inside of it under specific conditions. Rain-tight or watertight equipment may satisfy the requirements for weatherproof or equipment. Boxes with threaded conduit hubs and gasketed covers will normally prevent water from entering, except for condensation within the box. A lot of times these boxes aren't going to prevent 100% of the water from getting in. You're going to get some water in. Rain tight or rain proof means that if rain does get inside of the box, it's not going to affect the workings of whatever's inside the box. The box is designed in a specific way that any water intrusion is not going to cause a problem because they know that some water might get in. NEC section 314.15 states that approved drainage openings with a diameter between 1/8 inch and 1/4 inch are allowed to be installed in the field to allow the drainage of accumulated water from condensation. A wet location is any location subject to saturation with water or other liquids. A damp location is a location subject to some degree of moisture, including partially protected outdoor locations and interior locations subject to a moderate degree of moisture. So these are wet locations, underground installations in direct contact with the earth, installations in concrete slabs or masonry in direct contact with the earth, locations exposed to weather or water, garages, washrooms, interiors that might be hosed down. Damp locations are under canopies, under marquees, open porches with a roof, some basements, some barns, cold storage warehouses. Any underground conduit is a wet location, even if it's PVC pipe. You can put a pipe under the ground and it can be totally dry, and you can put duct tape over both ends and come back in 2 weeks. And that conduit will be filled with water just from condensation. The ground and the air heat up and cool off at different rates, so condensation forms inside the conduit. I've seen it many times on a job that you come back to a pipe that you installed and you cut the tape off of it and it's completely filled with water. You take compressed air and you just blow the water out and pull your wires in. And you use wires with a W, like THHW or THWN. Use a wire that has a W in the identification of the conductor, and it's good for a wet location. Let's see here. On to the next. 1.2.0, sizing outlet boxes. In general, the maximum number of conductors permitted in standard electrical boxes is listed in Table 314.16a. This number is based on box, trade size, minimum volume, and American wire gauge size. So here's a highlight. It says you must reduce the maximum number of conductors by 1 for each type of fitting in the box. Reduce the maximum number of conductors by 2 for each device strap. Count each looped conductor over 12 inches in the box as 2 conductors, and count up to 4 grounding conductors as a single conductor. All right, let's take a look at this. I'm gonna go to my 3D BB. There you go. That's a reference to an old cartoon. So here's a box, and here's a conduit coming. I'm going to go from this box to this box. Here are conduits. So we have different rules. A wire originating outside the box and terminating inside the box counts as 1 conductor. A wire that passes through a box unbroken counts as 1 conductor. A conductor that originates outside the box and makes now I'm going to say it in 2 different ways. I'm going to say a 6-inch loop, and I'm going to say a 12-inch loop, and different standards or different reference materials call it different things. In other words, if I have 12 inches of conductor here, if they say 12 inches of conductor forming a loop, that counts as 2 conductors. If they say a 6-inch loop, that counts as 2 conductors, because a 6-inch loop is actually 12 inches of wire extending in that box. You could cut it in the middle, then you'd have 2 6-inch conductors, and each one of those originating outside the box and terminating inside the box would count as 1 conductor. So a 6-inch loop, or what some people say, 12 inches of conductor forming a loop inside that box, counts as 2 conductors. The reason we're counting these conductors is because each box is good for a certain number and size of wires. The box might say that it can have 10 number 12 wires. This counts as 1, 2, 3, 4. So we only have enough room in this box for 6 more conductors. Okay. Any wire that originates inside the box and terminates inside the box doesn't count. So if I have a grounding screw, if I have a grounding pigtail screwed to the back of this box, it doesn't count. If it originates inside the box and terminates inside the box, it doesn't count. Now, up to 6 equipment grounds, I'll have to check on the number. It used to be any number of equipment grounds that all tie together with a wire nut. They count as 1 conductor, up to 6 of them. If you have 6 equipment grounds terminating in 1 wire connector, it counts as 1 wire. That's 1 deduction. If you have a second grounding system, there are occasions that you have a box that has 2 different grounding systems. You might have a solid green wire, and then you might have a green wire that has a yellow stripe. A lot of times you have this because you have what's called an isolated ground. So if you have isolated grounds and those isolated grounds are identified as green with yellow stripes, they also count as one conductor. You can't add them together with these other grounding conductors. Those two separate grounding systems count each as one conductor. Okay? If I put a device in my box, that's a terrible drawing, but here's a receptacle. And this receptacle is on a metal strap, and that metal strap is called a yoke. So they might say a strap containing one or more devices, or they might call it a yoke. The reason it says one or more devices is because each of these receptacles in a duplex receptacle, each one of these is a device. So this is actually two devices on one yoke. This is a deduction of two wires. Each yoke is a deduction of two wires. The exception to that is if you have a large, let's say you have a 50 amp receptacle on a yoke, and that 50 amp receptacle takes up two gangs. Here's a 4-inch square box, and usually we'd be able to put two switches in this. We'd be able to put a switch on this side and a switch on this side, or a switch in a receptacle. If this one receptacle by itself, that's a horrible drawing, but anyway, if this one receptacle takes up two gangs, then we have to do a deduction of 4 wires of the largest wire in that box. So if this takes up more than one gang, it's 2 wires per gang. 2 wire deduction per gang. And what they mean by gang is how many single gang boxes does this take up? If it is a device that took up 3 single gangs, then that device, you'd have to make a deduction of 6 of the largest conductor in that box. So, to recap, each wire originating outside the box and terminating inside the box counts as a deduction. Each wire that passes unbroken through the box counts as one deduction. Each wire that loops and makes a 6-inch loop counts as 2 deductions. Each grounding system of 6 or fewer grounding conductors counts as one deduction. If you have 2 of them, that also counts as a separate deduction by itself. There. This one has a wire nut. That's also one deduction. That would be a total of 2 deductions for those 2 grounding systems. And each yoke or strap holding one or more devices counts as 2 deductions unless those devices take up more than one single gang. Then it's 2 wires per gang deduction of the largest size wire in that box. If this is a 50 amp range receptacle and you're putting number 6 wires on it, then you have to make a deduction of 4 number 6 wires. Each wire takes up a certain cubic inch area, and that's 31416B. We can look at that in the code book. I'm going to get the code book out, and we'll look at 31416A and 31416B, and we'll read over these requirements. Let me go back. Okay, I'll tell you what. I'm going to go ahead and get out the code book because we've been going for about a half hour, so I'll stop this video. And the next video, we'll start with